In this video, we'll go through exam questions that cover the criteria, calculate values of angles and or coordinates with 2D and 3D shapes. You can locate the questions on the mathsmaths.com website under level 2. The questions come from different exam boards. We'll start with the non-calculated questions and then we'll move to the calculated questions. Here is the first one. Calculate the size of angle A. So angle A is in a triangle. Triangle has 3 angles as we can see, and we've got 2 of them given to us. One measures 80 degrees and the other one 30. So in total that is 80 and 30, which gives us 120 degrees. All 3 of them together will add up to 180. They always do in triangles. So what we're going to do now is 180, take away 120, that gives us 60. So angle A is 60 degrees. So the thing to remember that internal angles of triangles, they add up to 180 degrees, always. The diagram shows a regular polygon. A regular polygon, be it a regular pentagon, hexagon, or whatever shape it might be, it means, by saying regular, that it has equal sides and it has equal sized angles. So angle B here is the same as this angle here, or this one here, or this one, this one, this one, etc. So to work out the size of angle B, we're going to start with this full circle, which is 360 degrees, because a full circle has 360 degrees, and that's something we should remember. We have 1, 2, 3, 4, 5, 6, 7, 8 equal angles there. So if I divide 360 by 8, it should give me the size of each of these angles, including angle B. So how many 8s fit into 36? That is 4, because 4 times 8 is 32. 36, take away 32, leaves us with 4. How many 8s into 40? That is exactly 5. So angle B is 45 degrees. What is the perimeter of this triangle? So to work out the perimeter, we're going to add these side lengths. Are they equal? We don't know yet. We know this one is 24 millimeters, but we don't know about the other 2. How can we confirm? You can see that we have 2 angles given to us. This one 60 degrees and this one 60 degrees. So that is 120. If I do 180, which is the total of the 3 angles, take away 120, gives me 60. So this one is 60 as well. So this is an equilateral triangle, which means the angles are equal, but also the sides. So this is also 24 millimeters, and this is 24 millimeters. So what we're going to do is 3 times 24, or 24 at 24 at 24. 3 lots of 4, that is 12, so 2 down, 1 carried over. 3 lots of 2, that is 6, and the 1, that is 7, so 72 millimeters. The following diagram shows a parallelogram. What is the size of angle A? The way that angles are in a parallelogram means that if I draw here angle A, it fills this gap, and all together with 110 degrees that we have here, this angle, that will be 180, because this is a flat line. So this makes a semicircle. A circle was 360 degrees. A semicircle is 180. So 180 take away 110 should give me the value for this angle here, which is equal to angle A. So that is 70 degrees. What are the coordinates of the line at point star, or represented by a star? So that's this one here, which goes up to 5. So the x coordinate for the point is 5. And the y coordinate is between -2 and -4, so that is -3. So that is option B. What is the value of angle A? So we've got angles around the point here. So all of these in total will add up to 360 degrees because it's a full circle. We're given this one, which is 105, this one, which is 25, and this one is 90. So we have 105, 90, and 25, the three of them. 5 and 5, that is 10, so 0 down, 1 carried over. 1 and 9 is 10, and the 2 is 12. So 2 down, 1 carried over. 1 and 1 is 2, so 220 degrees. If I take this away from 360, should give me angle A. 6 take away 2 gives us 4, 3 take away 2 gives us 1. So that is 140 degrees. Calculate the value of angle X in this isosceles triangle. An isosceles triangle has these two side lengths which are equal, and these two angles at the base which are equal as well. So this is 32, so this is going to be 32 degrees as well. 32 and 32, that makes 64. So now if I do 180, take away 64, should give me angle X. Need to take away 4 from the 0, which means I've got to borrow 1. So this becomes 7, this becomes 10. 10 take away 4 gives us 6. 7 take away 6 is 1. 1 take away 0 is 1. So 116 degrees. Work out the size of angle X in this triangle. So we've got two angles given to us, 36 and 36. Which is 72. So 180 take away 72 should give us angle X. So we'll do 10 take away 2, which is 8. 7 take away 7 is 0. 1 take away 0 is 1. So that is 108 degrees. Work out the size of angle X. Again, we're given two angles, that's 42 and 85. 2 and 5 is 7, 4 and 8 is 12, so 127 degrees for the two combined. 180 now, take away 127, should give us angle X. We need to take away 7 from 0, so we're going to borrow 1. 10 take away 7 gives us 3. 7 take away 2 gives us 5. 1 take away 1 is 0. So angle X is 53 degrees. Work out the size of angle X and the size of angle Y. We've got these two little marks here which tell us that these two lines are parallel. With parallel lines like this, we know that this angle is equal to this one in size, and this one is equal to this one. So automatically X is equal to 115 degrees. Now also Y is the same as this angle here, so that and 115 degrees, they will make half a circle, which is 180. So if I do 180, take away 115, should give me angle Y, which is the same as this one, as I said earlier. So 10 take away 5 gives us 5, 7 take away 1 is 6, 1 take away 1 is 0, so 65 degrees. That's the size of angle Y. Whereas X is 115 degrees. We now move into the calculated questions. Here is a pentagon. The pentagon has one line of symmetry. What does that mean? If it has one line of symmetry, that must be here. So that tells us that this angle here is equal to 125 degrees as well. Work out the size of the angle marked X. I'll remove the line of symmetry just to make it easier to work with. So we can see these two are right angles, so these two will be right angles as well. A right angle is 90 degrees, so if I do 125 take away 90 should give me this angle here, which is part of the triangle. That gives me 35. So this is 35 degrees. Same thing on the other side. So this here is 35 degrees. Now 35 and 35, that gives us 70. So 180, which is all the angles inside the triangle, take away 70, gives us 110. So that's what angle X is equal to. Here is a coordinate grid. Write down the coordinates of point A. Point A is here. So we've got 5, -3. Plot point B with coordinates -4, 6 on the grid. Remember to label your point. So -4, which is here, goes up to 6. So that's point B. Plot a point C on the grid so that angle ACB is a right angle. Remember to label your point. ACB, so we're going to plot point C. I could plot it here. So ACB will be a right angle, or I can do it here. So that's another option. I'm just going to leave it there, and I'm going to label it with C. PQRS is a quadrilateral. Quadrilateral means it has 4 sides. You've probably come across quad, which means 4. Angles inside a quadrilateral add up to 360 degrees. It's like a full circle. If you put all these angles next to each other, they will form a circle. So that's one thing to remember. PQT is a straight line. So that's this one here. RQV is a straight line. Write down the value of x . We saw earlier with the parallel lines that this was equal to this angle. So x is equal to 84. Such angles are called vertically opposite angles. So we're going to write 84 degrees for angle x. Work out the value of y. Now, to work out y, we can use angle x, this angle here, which is 27 degrees, angle P, in other words, and angle S, which is 216 degrees. So if I add angles X, P, and S, and then take away the total from 360, should give me angle Y. So I'm going to do 84, add 27, add 216. That is 327 . 360 now, take away 327. Gives us 33. So this is 33 degrees. Write down the coordinates of point A. So there is point A, which is -4, 0. B is the point 2, 0. On the grid, draw a circle with diameter AB. So point B, that is 2, 0. So the diameter is 1, 2, 3, 4, 5, 6 units long. So radius will be 3. So that means this is the center of the circle. 1, 2, 3. That's another point in the circle. 1, 2, 3. So using a pair of compasses, you'll just go and join these points to make a circle. Mine doesn't look perfect because I can't use a pair of compasses. Archaeologists study human history by digging up and analyzing items from the past. Chen is a volunteer with the community archaeology group. At the weekends, she helps to dig at an archaeological site. The volunteers have to record exactly where each item is found. They do this by using a coordinate grid laid over a map of the site. The volunteers have found the wall of a building. It runs in a straight line from -125, 100 to 150, -75. Draw the position of the wall on the grid. So -125, that is here, and it goes up to 100. So that's 1 point. Then we have 150, which is here, and it goes down to -75. So that ought to be this point here. So we need to draw a straight line that connects these 2 points. So using a ruler, you will join these 2 points by a straight line. There is another way that the volunteers can record the position of an object. Measure the object's distance from a fixed point and measure the angle. See example in the diagram below. The volunteers find an object at the point 100, 100 on the coordinate grid. Mark the point on the grid in 4A. That is the question we've just done. So we're going to go and mark the point. So 100, 100, so that's the point there. The volunteers measure the distance of the object from the fixed point 0, 0, which is the origin. They then measure the angle. What size is the angle? So we'll show this on the grid, but to refer to this diagram we have here. The fixed point, that's the origin. The position of the item, that's the point we've just shown earlier. And this is the horizontal axis. So we're looking for this angle here. So this is the angle that we're after. As this point is in equal distance from both of the axes, this tells us that this is half of 90 degrees. So this is 45 degrees. So it's half of a right angle. Lottie reads that the best angle to launch the ball from for free throws is 50 degrees. Calculate the angles A, B and C. Looking at A and 40 degrees all together, they make 90 degrees. So we can do 90 take away 40 and that gives us 50. Because we've got to tick the ones which are 50 degrees. So that is 50 degrees. Looking at B, all together 35 and B and 65, they equal 180 or add up to 180. Got 35 and 65 which give us 100. So 180 take away 100 gives us 80. So B is equal to 80. It's not 50, so we will not tick it. Looking at C, it's part of a triangle. So we've got 65 and 65, which gives us 130. So 180 take away 130 gives us 50. So we can tick this one as well. So it's A and C. The group need to build a ramp between the hospital door and the gardens. The angle of the slope of the ramp must not be more than 5 degrees. This is the diagram of the ramp. Calculate the angle of the slope. So the slope angle is this one here, which we need to work out. What we know is this one, which is 90 degrees because it's a right angle, and this one here is the same as this one, so that is 86 degrees. So if we add 90 and 86, gives us 176. 180 degrees, take away 176, that gives us 4. Jan is an apprentice in a theatre. She needs to plan the layout of the stage for the next play. A prop is an object used on stage. One of the props is a cylinder with radius 1.5 meters. Jan uses a coordinate grid to plan where to put props on the stage. Each small square on the grid represents a 1 meter by 1 meter square on the real stage. She wants the center of the cylinder to be at -3, 2. On the grid, draw a plan view of the cylinder in this position. So center of the cylinder will be at -3, 2. So there is -3 going up to 2, so that's the center of the circle. I'm saying circle because the base of a cylinder is a circle. And the radius is 1.5 meters. So this is 1 meter. So this is 1.5, 1, 1.5, 1, 1.5, here 1.5. So with a pair of compasses, you'll draw a circle like so. The coordinate grid shows the space for the car park. The car park is rectangular. It measures 120 meters by 100 meters. Each square on the grid represents 20 meters by 20 meters. Pavel draws 2 vertices and 1 edge of the car park area on the grid. Write down possible coordinates for the other 2 vertices of the car park. So the car park is rectangular. It measures 120 meters by 100 meters. As each square on the grid represents 20 meters by 20 meters, so 120 divided by 20, that gives us 6. So the length is represented by 6 square lengths, so we've got 1, 2, 3, 4, 5, 6. So we're going to go down or up 5 square lengths, because 100 divided by 20 gives us 5. So we could go down 1, 2, 3, 4, 5. So these are 2 possible points. We've got 4, 2 and 10, 2. Or if you went up, so you go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that would be 4, 12 and 10, 12. Whichever you prefer. I went with the first one. You could go with the second one if you like. But you need to pick one, not show both. Judy has this plan view of a section of the water pipe system in a building. She knows that the sum of interior angles in a pentagon is 540 degrees. Calculate the value of angle X. So we know this is 90 degrees, this is 90 degrees, and this is 90 degrees. So 3 right angles. We've got 130 here as well. So if we add 130, 90, 90 and 90, and then take away the total from 540, should give us angle X. So this is what we're going to do. That gives us 400. So 540, take away 400, that is 140. Five corners of a hexagon are drawn on the grid below. What are the coordinates of the 6th corner? Write the answer in the box below. So we're given 5 corners of the hexagon. It seems to be a regular one, which means that the sides have equal length and so have the angles, equal size. So we've got 1, 2, 3 square lengths here. So we're going to go 1, 2, 3. So that will be the next corner, the missing corner. What are the coordinates? So this is -1, -2, and this is 1. So -2, 1. The diagram below shows an isosceles triangle with 2 equal sides and 2 equal angles as marked. Calculate the value of angle Z. Show your working out and write the answer in the box below. So we know that this angle here is the same as Z. It has the same size. So to work out Z, what we're going to do is take away 23 from 180. And the answer will give us the total of this angle here and Z. So 180 take away 23 gives us 157. So now, as this is the same as Z, I'm going to divide 157 by 2 to give me the size of angle Z, which is 78.5. Three corners of a rectangle are marked on the grid below. What are the coordinates of the 4th corner? Write the answer in the box below. So we have so far 3 corners, the 2 sides. So we're going to work out the missing corner. So from this corner, I'll go 1, 2, 3, 4, 5 down, and then 1, 2, 3, 4, 5 to the right. So I'll do the same with this corner. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So the missing corner is right here. What are the coordinates of it? This is -3 and this is -6. Which point has the coordinates -2, 3? So start from -2 and going up to 3. That is point A. Here is an isosceles triangle. AB is equal to AC. So this side is equal to this side. This also means that this angle is equal to this angle. We need to work out the size of angle X. So we'll start by working out this angle and this one. So we only know this one, which is equal to 36 degrees. So if we take it away from 180, should give us the total for this one and this one, the two angles at the base. So that is 144. So 144 now divided by 2 gives us 72. So this is 72 degrees and this is 72. Now 72 and angle X combined are angles on a straight line. So that's half a circle, which is 180 degrees. So 180 take away 72 should give us angle X, which is 108. A is the point 1, 2. B is the point 3 squares west of A and 5 squares south of A. Work out the coordinates of B. So 3 squares west of A. So this is north, this is south, this is east, and this is west. So we're going 3 squares west. So that's 1, 2, 3, and 5 squares south. So that's 1, 2, 3, 4, 5. So that is point B. Coordinates are -2, -3. Here is an isosceles triangle. Work out the size of angle X. So isosceles means that this angle is equal to this one. So this will be 42 degrees as well. So we have already 42 and 42, which is 84. So now to work out X, we'll do 180 take away 84. Which is 96. So X is equal to 96 degrees. And that's the end of the questions.